Okay, so this is the review. This is not going to be my best work because I'm just using the program it's in. So let's see. So this first part, you're trying to decide if it's acute, obtuse, or right. So this is where we did converse of Pythagorean theorem. It was 5.2. Sorry, I'm trying to get it to... There we go. Okay. Nope, not letting me write. Sorry. That one's going to stay yellow. Sorry. So, if we do a squared plus b squared, and that equals c squared, that's Pythagorean theorem. That means it is a right triangle. But if c squared is smaller than a squared plus b squared, that means that angle is smaller, so it's acute. If c is bigger, the angle's bigger, and it's obtuse. So we'll do 9 squared plus 12 squared, and then I do a blank and do 15 squared. So 9 squared plus 12 squared, you can do all in one step in your calculator, you'll get 225. 15 squared, you also get 225. So those are equal, which makes it a right triangle. We'll do 5 squared plus 12 squared, a blank, and 13 squared. I don't do equals because it doesn't always equal. It does on these first two though. If you type that in, you get 169. That's 169, so those are equal, and it's a right triangle. But this one's not. 9 squared plus 14 squared, 15 squared. Now I know 15 squared is 225. 9 squared plus 14 squared is 277. So that's bigger. So C, we're always looking at C. C is smaller. So C is small. That makes the angle small. And it's a cute little angle. Okay, on this one, first of all, what you need to do is type in, I'm not going to be able to show you that. Okay, you would need to type 4 radical 2 in your calculator and see what the value of that is, because it could be the biggest side. It's not. I think 4 radical 2 is like 5 point something. Let me do it in my calculator here. 4 radical 2 is 5.7 roughly. So it's one of the smaller sides. So you either have to do this whole thing in parentheses, or I would do it in 2 separate steps. Like I'd just type 4 radical 2 and hit enter. You'd get like the 5.6568 blah blah blah. And then immediately hit x squared, so it'll do the whole thing squared. You should get that that's 32. If you get that it is, let's see, 8, it's because you're not squaring the 4, because you haven't put parentheses around it, which is why I just recommend doing it in separate steps. Sorry, blank 9 squared, so that's 81. So 40, wait, let me square that, make sure it's 32. Yeah. Plus 49. So we end up with 81 on this side, 81 on this side. Those are equal, so this one's a right triangle. You might want to pause it because I'm going to erase this so I can show you the 4 radical 2 in the calculator. Like I would do 4 radical 2 first, hit enter, make sure it's not the biggest side. Then I'd hit this x squared button and it would square that whole answer. If you just do this, which most people do, it only is going to square the radical 2 and then just multiply it by 4. It doesn't square the 4. So be careful about that. Okay, let me see if I can go ahead and scoot this down a bit. You'll notice by my clock that it's 1:46 and my conference ends at 2:01. So let's see if I can finish this. So we have 22 squared plus 58.2 squared and then 62.5 squared. When I square those and add them together, I get 3871.24. I get 3906.25 on this one. This one is bigger, C, which makes it obtuse. Okay, square root of 240. I don't know what that is, and I'm not going to clear this to show you with the calculator, but I know that it's going to be the biggest side because 12 squared is 144, so it's at least more than 12. But you do have to make sure it's not the biggest side, or it is. It just matters for where you put it. So I know 240 squared should get me just 240. Do not square it again. You've already squared it when you take away the radical. 12 squared is 144 plus 100 is 244. So this is bigger. So C is smaller, which makes the angle smaller, and it's a cube. All right, then if you have two sides and you're finding the third side, that's Pythagorean theorem. That's a squared plus b squared equals c squared, where c is the longest side. So this is c, this is c. That's a hypotenuse. It's across from the right angle. So we do 9 squared plus 12 squared equals x squared. 81, 144, and you can actually go ahead and add those in your calculator. It doesn't matter. If you do that in one step, you just get 225 equals x squared. If you can take the square root of that and get a whole number, do that. On this one, you'd get 15. Perfect. This one on the test, I'm going to actually let you just round to the nearest whole number. I'll show you both ways on here, though. So we have 4.2 squared plus 4.4 squared, and that equals x squared. So I'm just going to do that in my calculator. Square those and add them together all in the same step. You get 37. So then you take the square root of both sides. Now if you take the square root of 37, you get 6.08. So tomorrow on the test, I'm going to have you just put like x equals 6, because I'm going to have you round to the nearest whole number. But on this one, since it says simplest radical form, this is actually the correct answer. Sorry, it makes me erase it. So I have 4 squared plus radical 17 squared equals x squared. So 4 squared is 16. Radical 17 squared is just 17. You do not square that again because you've already squared it when you take away the radical. So when I add those together, I get 33. So then I've got to take the square root of both sides to get just x. And 33, if you break it down, is 3 and 11. There are no pairs, so that's just radical 33. This one's x squared plus 6 squared equals 15 squared. Now this is where you're going to have to subtract because the x is not the hypotenuse. So I'm going to go ahead and square them. Then I'll subtract. Let me change colors. So I get x squared equals, let's see, 225 minus 36 is 189. Then I'm going to take the square root of both sides. Now when I break down 189, let's see, 21 and 9, that's 3 and 3. That's 3 and 7. So we can bring out a pair of 3's. And then we have a 3 and a 7 left over, so that's a 21. Whatever's left over, you multiply back together. These go in the same exact order on your test. There's a fewer number. I think there's only 26 on your test. And there's 28 on the review, but like right after Pythagorean theorem, you're doing trig on the test, just like you are on this paper. Okay, so if this is our angle, that angle is made up of this side and this side. One of those will always be the hypotenuse, the other is adjacent. So the hypotenuse is the one across from the right angle. That makes this one the adjacent side. The one that does not touch the angle is the opposite. Then we have to see what are we even using. We have to use what we're given, that's the 14, and what we're looking for, that's the x. So you would look at your formula chart and ask which one is O and H. I'm going to write up here SOHCAHTOA, just so we have it. But these are on your formula chart. So O and H is sine. So you put sine of the angle, and that should equal O over H. When the variable's on top, you multiply. So you should be typing in your calculator 14 sine 41. And you should get 9.2 once you round it. Now, it was not on purpose, but all 4 of these on your review are multiplication like this because the number's on bottom. So let's just pretend I'm going to make one up. Like say we have the cosine of 52 equals 19 over x. If the variable's on bottom like this, you take this and you completely switch them, and then you divide. So now we have x over here and cosine of 52 down here, and we'll do 19 divided by the cosine of 52. None of those are like that on the review. I didn't do that on purpose. I made sure there was a sine, cosine, and a tangent, but I forgot to check that. I gotta erase this because that's gonna bother me. Okay, our angle is made up of this side and this side. The hypotenuse is the longest one. The other must be adjacent. The one that doesn't touch it is opposite. We're looking for the adjacent. We have the hypotenuse. That is cosine. So cosine of the angle is adjacent on top, hypotenuse on bottom. Multiply both sides by the 19. So you should be typing 19 cosine of 38 in your calculator. Make sure you're in degree mode, not radians, but you should get 15.0. I know that you get, let me actually type it and see what you get. Sorry, I'm using my work from earlier. You get 14.97. So the 7 makes the 9 go up, which makes it become a 10, so then you have to carry the 1. But you still have to put the 0 there, if ever that happens. Alright, this angle is made up of this side and this side. Let me go ahead and highlight this angle. It's made up of this side and this side. So, the hypotenuse is the longest side. The other side that makes up the angle is the adjacent side. It all depends on which angle. So like this could be the adjacent side if it was this angle we were given, but it's not. So that's why you can't just memorize a picture on that. It depends on which angle you're given. Other side is opposite. So we're looking for adjacent and hypotenuse here, but adjacent and opposite here. So this is cosine 36 equals x over 14. Multiply both sides by the 14. So you're doing 14 cosine 36. You should get 11.3. On this one, you're doing tangent of 31. That equals, tangent is opposite on top, adjacent on bottom. You'll multiply both sides by the 14. So you should type 14 tangent 31, should get 8.4. Might want to pause it because I got to erase it to scroll. Okay, so these are still trig, but it's inverse trig and a little easier. So here's our angle. This is the hypotenuse. This is the other side of the angle. That's opposite. This is hypotenuse, hypotenuse, hypotenuse. That's the longest side across from the right angle. The other one touching the angle is adjacent, adjacent, adjacent. The one not touching the angle is opposite. So on this one, you're going to use the two that you're given. So that is cosine, but now your x is right here. So cosine of x equals adjacent over hypotenuse. So when you don't know the angle, you do second cosine, which brings up cosine of the -1, and you do 5/6. Now this one's rounding to the nearest degree, so that means nearest whole number, so you should get 34 degrees on this one. This one is adjacent and opposite, so that's tangent. So tangent of x equals 31/34, because tangent is opposite over adjacent. So in your calculator, you'll hit second tangent, 31 divided by 34, close parentheses, should get 42 degrees. This one is adjacent and hypotenuse, so that's cosine. Adjacent on top, hypotenuse on bottom. Oh, I did that wrong. I wish I had an undo button on this. So you do second cosine, and it brings up this -1. That's the inverse. And you should get 41 degrees. Then we've got opposite and adjacent. So that's tangent, and you do 9/12, so you'll do second tangent, 9/12. You'll get 37 degrees. Okay, I may have time for just a couple of these. Okay, so this is a 30, 60, 90. This is the key side, so you're always going to or from this side. So if I'm going to that side from the long leg, I know this is a short leg, this hypotenuse is the long leg. I should be dividing by radical 3. So that looks like this. 6 divided by radical 3. Now, when you divide radicals, you cannot leave a radical in the denominator. So you have to multiply the top and the bottom by radical 3. When I do that, I get 6 radical 3 all over the whole number 3. You can put radical 9, but square root of 9 is just 3. Then I can reduce 6 divided by 3. That's a 2, that's a 1. So really it's just 2 radical 3. Then to get from there to the hypotenuse, you just multiply by 2. You're just multiplying the outside number because it's like variables. So this is like taking 2x and multiplying by 2 and just getting 4x. You just get 4 radical 3. Don't change the radical at all. This one's a little bit easier to get from the hypotenuse. Sorry, I should label these. Short leg, long leg. From the hypotenuse to the short leg, you're dividing by 2. So 6 divided by 2 is 3. Then to get to the long leg, you're multiplying by radical 3. So you get 3 radical 3 for x. On this one, it's the same thing as this one, just with radicals. So if I'm going from the hypotenuse to the short leg, I should be dividing by 2. So 2 radical 3 divided by 2 is just radical 3. Now I multiply that by radical 3 to get to the long leg. So radical 3 times radical 3 is just 3. You can also put radical 9, but once you take the square root of 9, you should just get 3. This is a 45, 45, 90, so this should also be 3 radical 2 because the legs are the same. Then to get to the hypotenuse, you multiply by radical 2. 3 radical 2 times radical 2. When I multiply these together, radical 2 times radical 2 is just 2. So 3 times 2 is just 6. So that should be this answer. Okay, so just a few more questions. We're still on 45, 45, 90 triangles. Sorry, I don't like it when it gets highlighted. I don't like the blue box either. Okay, so this is a 45, 45, 90, so the two legs are the same. So this one would also be 6. Then to get to the hypotenuse, you just multiply by radical 2. So that's 6 radical 2. On this one, these would be the same. So this is just 2 radical 2. Then to get to the hypotenuse, you multiply by radical 2. So 2 radical 2 times radical 2. You just do those together first. Radical 2 times radical 2 is just 2. So then you get 4. These down here are T and L pattern. This one's L because we're looking for a leg. This one's T because we're using the altitude. So L pattern starts here and goes towards the leg you're looking for. So we don't know that, so you'd have to do 100 minus 64, which is 36. So this part right here must be 36. So it's 36 over x, because it's part of the hypotenuse over the leg. And that equals the same leg, so back this way, over the entire hypotenuse, which is 100. Cross multiply, you get 3600 equals x squared. Take the square root, you should get 60. Okay, and then for T pattern, you're also going to have to subtract that, because T pattern is part over altitude equals altitude over the other part. So you got to get this part's 25. You just subtract 175. So it should be 75 over x equals x over 25. And you could also do 25 over x equals x over 75, either way. So 75 times 25 is 1875. That equals x squared. And when you take the square root, that's not a whole number, so you gotta simplify it. I would do just 75 and 25 because I just multiplied those together to get it. Then we've got 5 and 5, 3 and 25, and 5 and 5 again. So we have a pair of 5s, another pair of 5s, and a 3 left over. So you should get 25 on the outside and radical 3 on the inside. That's what x is. I didn't write x equals, but you can. Okay, 2 more. So let's see. If I draw an equilateral triangle and a square, now let's see if I can do a perfect line down the center. Oh, that's not perfect. That one's better. See, that's not even my fault. That's just pixels. I can't do anything about that. So let's just pretend that that's right down the middle. I don't know if I can pretend though. That's terrible. That's awful. Okay, I'm just going to draw this right triangle in. We're just going to pretend like it's perfect. So when you have an equilateral triangle, these are all 60 degrees, this angle, and then this top angle are all 60. But when you cut it with a height, it makes that 30 and 30. So you have two 30, 60, 90 triangles. When you cut a square, it makes the diagonal cut this angle into two 45, 45, 90 triangles. So then we can apply our rules there. So if this has a perimeter of 54 feet, the first thing I'm going to do is take 54 and divide it by 3. and get 18, which means that all the sides of the triangle are 18. But since this one's cut in half, it's 9 and 9. And since it's a 30, 60, 90 triangle, I just have to multiply by radical 3 to get the height. So it would be 9 radical 3. So area equals 1/2 base times height. The base of this triangle is 18. You still use the whole base. The height is 9 radical 3. Now when you multiply that, I'll do this in 2 separate steps. The first thing I'm going to do is multiply 1/2 times 18, because you don't distribute like a lot of people think. Do 1/2 times 18 and get 9, and then you still have this. Then you'll multiply 9 times 9 and get 81, and the radical 3 just comes down. So I did this first to get this, and just brought this down. And then on the next one I did 9 times 9 to get 81. And this one's a little bit easier actually. If the perimeter is 400, take that, divide by 4, you get all the sides are 100. But I'm not even asking for area, I'm just asking what is the diagonal, which is the length of this thing right here. So all you have to do is take a side, multiply by radical 2, you get 100 radical 2. So the diagonal is 100 radical 2. And that's it.